extractor. This is where you come into, and it has a little verbiage about be careful about contacting the correct PI to share data or to publish data. So it's like a license agreement to be able to use the system. So you can't do anything until you've agreed. So you have to have a password to get in. And then these are your options to select a data set or to extract by samples and markers. So if it was samples, it gives you options to enter either copy and paste the list in or upload a file. And the same for markers. Copy and paste or list a set of markers. It's very easy to just copy and paste markers into there. So I'm going to extract my data set. And you just want to find your PI.
How about just extract the one I loaded this morning so they see the entire loop?
I haven't got that extracted already. I wasn't going to wait for the email. And you want to select your project. And you see this little red button here. It's saying I haven't selected enough information yet to be able to extract. So I'm going to select a particular data set to extract. And then up here is the format. So I want to select Flapjack and the map and submit. And that's it. Submitted, you'll get an email back. And I'm just going to show you what the extract looks like for simplicity. These are the data that I get back. So I'm going to actually open them in Excel. So exactly as you loaded the sample metadata, it has all of the relevant names that you loaded. And see, I've just got an email back that the extract worked. This is one I did earlier. It tells you the project name, the PI, all the information you need about the sample is in here. Same for markers. Has all of the marker names in my data set, what kind of platform it is, all my sequence information that I might need if I wanted to do some kind of blast. So all of that is in there. And then most importantly, my data set. So this is what we need for Flapjack. So this is the format that you're going to import a file into Flapjack. You can get this from GOBii, or you can get it from Milka's pipeline, or you can create your own. It's a fairly simple format. It just has this. The only thing that's specific for Flapjack is this little hash space FJ file equals genotype. And then it's a very simple matrix. You have your sample name down the side, and you have your marker name across the top. This is obviously a codominant file. Missing data is ends in here. I think for the examples today, there will be the 2-letter genotype ones. And then we need a map. And the map looks like, okay, so, hang on, this is the map set. There's a metadata file that gives you all of the map locations that marker has in the database, so how many different markers it's been mapped to. And then there's also another file that is specifically used for Flapjack. So again, it has the little FJ header at the top. You can specify what the ends of the chromosomes are. I've got 4 different chromosomes here, and I've got no information on what the end position of the chromosomes. The reason why you might want to know the end of the chromosome is if you're doing MADC and you want to know what the linkage drag is for the QTL compared to the rest of the chromosome. So it'll do a % of the QTL that you have in the recurrent parent. And then all I have are my markers and the positions on the map. If you don't have positions on the map, it doesn't matter. Flapjack will just assign random positions for you, and it will import them in order. Okay, so this little icon, I don't know whether you can all see, it's a little checkered icon, is opening Flapjack. Has everyone had a chance to open Flapjack yet? So all you do is click on this, and it will take a moment to load. But this is what you're going to see when you come into Flapjack. And Carlos will go through this again step by step. So if you can just watch for now, just to get an overview of what to do. So you want to import the data into Flapjack. For the 2 files you need, or the 1 file you need is the genotyping file actually. You have a map, you put the map file here, just like I showed you. And then you import the map genotypes. You do have advanced options here. You can specify what the missing data field is, or how the heterozygotes are separated. So this is basically what you're going to see when you come in, and you can see it's pretty much a mirror of the genotyping plan that I just showed you. The samples are down the side and the marker names across the top. And to see the marker names, you kind of have to hover over the genotyping scores. You can see at the top here that you're seeing the marker name in that bar across the top. Now there's 4 chromosomes here. So there's kind of normally Flapjack just shows 1 chromosome at a time. If you want to see all 4 chromosomes at once, like this, see at the top, I'm showing all the chromosomes. It'll kind of just glue them together. It looks a bit funky, but it's just like a fix that Flapjack had put into place, because they started out with thousands and thousands of markers, and it made sense to only see 1 chromosome at a time. For marker-assisted breeding, we want to see everything in 1 frame. So this is where we've kind of squished it all together. So this first set of genotypes are chromosome 1, and then the second set of genotypes of chromosome 2. There's a chromosome here across the top, and then down at the bottom it will give you a summary view of whatever you're hovering over. So it'll say what sample you're on, what marker you want. Okay, so that's the basic overview of Flapjack. Carlos, are you going to do the genetic distance analysis? I'll just quickly show you this. It's a really nice way to get a first view of your data. What's that? So one tool that Carlos probably won't be showing you, he's going to show you this analysis down here, pedigree verification. And if we get time, we'll move on to marker-assisted backcrossing. But a couple of simple tools is you can just sort very quickly by line. So I can compare everything to this first line up here, and it will sort them according to distance. I can do a similarity matrix. This just shows you the heat map view. Unfortunately, when you haven't got many samples, it looks a bit weird. But you can create a dendrogram. It's not a very